Okay, so we did section 5.1. We got 2 new basic graphs, and then where we ended our time was by finding vertical asymptotes. So remind me, where do vertical asymptotes occur? What do I have to do? Any idea at all? I know, it's Monday, your brains are barely working. You probably just got up 5 minutes ago. I get it. I've left our problems on the overhead. There's your hint, your reminder. When I need to find a vertical asymptote, where do I look? The denominator, yes. What is true about the denominator where a vertical asymptote occurs? Okay, great. So just a quick warm up, just to get us back on track to that point. Here's what I would like you to do. Okay, just flip over your packet. This is not a sheet on the packet. This is just a little extra one. I just want you to real quick find the vertical asymptote. It's going to take you like 5 seconds of this function. Find the vertical asymptote of that function right there. F of x is 3x plus 5 over 5x minus 2. I'm going to give you 75 seconds to do that. And then we're going to get rolling on the next stuff. I do. Yes. You're welcome. Glad you're here today. All right, so the vertical asymptote of this right here. Again, here's the process. We're going to employ this today, okay? Because this is part of our process of graphing rational functions. Take the denominator, right there. We have no concern for the numerator when we're finding the vertical asymptotes. It does not matter what the numerator is. What only matters is the denominator, so 5x minus 2 is equal to 0. Add the 2 over. 5x is 2, divide by 5, and you should get that the vertical asymptote occurs at the x value 2/5. Okay, this is not a solution. This is a line of interest, so it stays as a line, x equals 2/5. If you just write 2/5 on the test, well, then there's going to be a problem because I'm not going to know what you're referring to. Are you referring to the horizontal asymptote, the vertical asymptote, or any other information that we're going to get? So make sure you leave it in this form, x equals 2 over 5. That's great. And remember, all the fun stuff in our rational functions, when we do the graph, all the fun stuff happens around the asymptotes, the vertical and the horizontal. So that takes us now, we are caught up to where we were. I'm going to change cameras here. Doesn't change your view at all, but for those watching at home.
There we go. So this is where we left off. We had talked about the vertical asymptotes and we found the vertical asymptotes for the 5 problems. Now we're going to get to the next bit of information. We are going to find the horizontal asymptotes of some of these. I've given different functions. We're going to find the horizontal asymptotes of. So the process, remember, we had 2 basic functions last time. You just need to remember those, and you're on the test, the first couple problems. I'm going to give you a basic function. You're going to do some translations and stretching and shrinking. But notice these problems right here, these are not in the format of either of our basic functions. Okay, it's not a 1 over x, it's not a 1 over x squared. Okay, so these are more complicated rational functions. So we need a different process that's a little more involved. So step 1 of this process is we find the vertical asymptotes, and then step 2, we're going to find the horizontal asymptotes. Now here is how we find the horizontal asymptotes. Okay, there are two possibilities that you're going to have. Now I've kind of written where I wanted to write the 2 possibilities, so I'm going to move over here a little further to the right, there are two possibilities for the horizontal asymptotes. I'm just going to abbreviate because I'm really clever, HA. And it has to do when you compare the highest power in the numerator and denominator. So the first situation is this. If the highest power in the denominator is greater than the numerator, then the horizontal asymptote is the line y equals 0. Okay, it's the same horizontal asymptote as we have when we graph our basic functions. Okay, y equals 0 is just the x-axis. Okay, so you can make a note right there if that would confound you. Okay, so if the highest power in the denominator is greater than the highest power of the numerator, then what that means is that the values in the denominator are going to get bigger faster. It's going to win, and the horizontal asymptote is y equals 0. I'm going to give you a moment to write that down. And then of our examples, there is just one that meets this criteria. So what I would like you to do, okay, don't shout it out because everybody writes at a different pace. What I would like you to do is, of those 6 examples, just circle the one that the highest power in the denominator is greater than the highest power in the numerator. Okay, there's one, actually, I take that back. There are 2 problems. So circle both of them. There's 2 problems where the highest power in the denominator is greater than the highest power in the numerator. Which 2 functions of these 6 right here did you identify as the ones that have the highest power in the denominator is bigger than the highest power in the numerator? Yeah, the first 2. Okay, so just in case you don't know what I'm referring to, I apologize if that wasn't super clear. Notice in this first problem, what's the highest power in the denominator? X squared. What's the highest power in the numerator? X to the first power. So that's what I mean. The highest power in the denominator is bigger than the highest power in the numerator. So this first one, I'm just going to circle the function part. That meets this criteria. And the horizontal asymptote of this is y equals 0. The next one. The first 2 I was told. This next one, I'll circle this one as well. Again, notice the highest power in the denominator is greater than the highest power in the numerator. I'm going to circle those powers. The highest power in the denominator is a 5. The highest power in the numerator is a 3. So once again, the denominator is going to win. The values in the denominator are going to get bigger much, much quicker. And so the horizontal asymptote again is going to be y equals 0. So if it wasn't super clear before, do you understand what I'm referring to, or can you visualize what I'm referring to when I say that the highest power in the denominator is bigger than the highest power in the numerator? Okay, you know where you're looking. When that happens, you have no calculating to do, no figuring. The horizontal asymptote will be y equals 0. Now, the other situation is the other 4. Notice what's true about the powers, the highest power in the numerator and denominator of the other 4 problems. They're equal. Yes, thank you very much. Okay, so please observe that. If anyone does not see why we can make that conclusion, please let me know. But the highest power in the numerator and denominator of the other 4 examples are equal. It's 2 in this problem. When I skip down here, it's 2 in this problem. In the last 2, it's 1 is the highest power in the numerator and denominator. So in that case, if the highest powers are equal, if the highest powers are equal, then the horizontal asymptote is the ratio of the coefficients of the highest power terms. And that is a lot of writing for something that is going to turn out to be fairly simple, I think. And if I'm wrong, please let me know. So if the highest powers are equal, then the horizontal asymptote is the ratio of the coefficients of the highest power terms. So I'm going to do the third problem, and then I'm going to give you a minute or two to find the horizontal asymptote of the other three. So notice in this third problem right here, the powers are equal. We already noticed that. So the horizontal asymptote is going to be this. What's the coefficient of the highest power term in the numerator? 3. The coefficient means the number out in front. I'm going to circle it. 3. What's the coefficient of the highest power term in the denominator? Yeah, the 1. There's no number written there, and so we always assume a 1. And so I'm just going to reduce that. The horizontal asymptote is the line y equals 3. That's how you find the horizontal asymptote. So again, lots of words. I'm hoping you can summarize it in your brain. If the power in the denominator is bigger, the horizontal asymptote is always y equals 0. If they are equal, then it's the ratio of those coefficients. And a question you might have is, hey, Perkster, what happens if the numerator's power is bigger? That would be a great question. You don't get a horizontal asymptote, you get what's called an oblique asymptote. We're not going to talk about those in this class. That's a little pre-calculus stuff. So if you're excited about that, then pre-calculus is going to be the place for you. All right, so please do me this favor. Find the horizontal asymptotes of the next three problems. Okay, so here goes the horizontal asymptotes. So this next one, the horizontal asymptote, the coefficient of the highest power in the numerator here is -1. The coefficient of the highest power in the denominator is +1. So that horizontal asymptote is the line y equals -1. For the next one, the coefficient of the highest power in the numerator is 1. The coefficient of the highest power in the denominator is 1. So that horizontal asymptote is 1. And then the last one I have right here, the horizontal asymptote, the coefficient of the highest power in the top is 1. The coefficient of the highest power in the bottom is 3. And so that horizontal asymptote is 1/3. All right, before I move on, anybody struggling on where to look to find the horizontal asymptotes for each of these graphs? We doing all right? Questions, comments, concerns? All right, so how are we going to graph rational functions? Well, I've tried to boil it down to 6 things that we need to do. Okay, so hopefully this is a help, not a hindrance. And so we're going to do these things along with, on the next page, the problem here, x - 1 over x + 4. This is going to be my example. And then I'm going to have you work through the example on the second page, x + 2 over x - 3. So here we go. So the first thing that we are going to do when you are asked to graph a rational function that is not in the format of one of your basic functions, first thing is find your vertical asymptotes. That's step number 1. And I'm going to put in parentheses, that also tells you the domain. We talked a little bit about the domain last time when we were looking at our basic functions. So you're going to find your vertical asymptotes. That also tells you your domain. So I'm going to flip the page. I hope I don't make you too dizzy. I'm going to flip to the problem. So this is the problem that we are going to work through right here. It's x minus 1 over x plus 4. So step 1. We are going to find the vertical asymptote. Well, the good news is we already did that last time on the previous page. So you can look back at your notes. The vertical asymptote we found last time the very first example was the x value of -4. And we got that by setting the denominator equal to 0. Okay, that's from the front page. So what I'm going to do first is I'm going to now make a nice dotted line right here at the x value -4. Quick quiz. Does a graph ever go through a vertical asymptote? No, it will never go through, ever, ever, ever. Okay, so that starts to tell me a little something about the graph. We know that the graph is going to, depending on if it's going to go up or down, which we'll figure out, depending if it's going to go up or down, as the graph gets closer and closer, it's either going to go up or it's going to go down. That's what happens at a vertical asymptote. All right, step number 2. Step number 2 is we are then going to find the horizontal asymptotes. Oh, that's great. We just did that. So I'm going to flip the page. We didn't do this one on the previous page. We did one super similar to it. So step 2, the horizontal asymptote. So please tell me, is this problem right here, is this the situation where the power in the denominator is bigger, or is this the situation where the powers are equal? They're equal. Okay, so the highest power in the numerator and denominator is 1. So the horizontal asymptote, since they're equal, are the coefficients. And so in the numerator, that coefficient is 1. In the denominator, that coefficient is 1. So my horizontal asymptote is the line y equals 1. Okay, beautiful. Let's do that. So here's my cute little dotted line. Dot, 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 dot. So really all that remains is we just need to get a little more information to know where is the graph and how is it interacting with those asymptotes. Okay, now this is my expectation when test time comes. When I give you a problem that's based on the basic functions, I expect a little more detail because we plotted some points and we did that. On these, we're just trying to come up with a sketch. Okay, it's not going to be perfect and perfectly precise. Okay, so what I do here is my expectation. We're just going to now try to figure out some easy points that gives me a feeling of what's going on. So here's the next thing that we're going to do. Step 3 is we're going to find the Y-intercept. Now that sounds intimidating, but the reason that I want to find the Y-intercept is that means I can plug in x equals 0. And if you've been with this class since the beginning, you know my fondness for plugging 0 into functions. Okay, 0 times anything is 0. It makes it lots of fun. So we're going to go back here to my second page. Again, we're making you dizzy if you're watching the video. So step 3 is we're going to find the Y-intercept by plugging in the x value 0. So the function value at 0. Well, in the top, that is 0 minus 1. In the bottom, that is 0 plus 4. And so 0 minus 1 is -1. 0 plus 4 is 4. So at the x value 0, the y value is -1/4. So negative just a little bitty bit right there. Now don't draw anything just yet. We do have one other thing, but that gives us a bunch of information. That dot, along with the asymptotes, pretty much tells us almost everything we need to do for the right half of this graph. Because remember, asymptotes define the behavior of the graph. We'll come back to that though. We'll get the satisfaction of drawing this in a minute. The fourth thing is we are going to find the X-intercept. And the way we do that is we set the function equal to 0. I'll give you a second to write that down. So the nice thing, though, that sounds like a lot to do. So here's my fourth thing. We're going to find the x-intercept. Where does this go through the x-axis? So I'm going to take my x minus 1 over x plus 4 and set it equal to 0. But here's the good news. When is a fraction equal to 0? When what part of the fraction is equal to 0? When the denominator is 0, I get my vertical asymptote. That's when it's undefined. So what's the other part? The top. 0 divided by anything is 0. So even though this looks complicated right here, and when we come back on Wednesday, we're going to talk about solving rational equations, all you have to worry about for this is basically you're setting the numerator equal to 0. So what I have is x minus 1 equals 0. So that means x is 1. So my x-intercept, where it goes through the x-axis, is at x equal to 1. So I'm going to make a little dot over here. 1, 0. The y-intercept, remember, is just a smidge down, okay, at -1/4 or -0.25. I am really excited. We are just about to the point where we can connect those dots, but I have one more question I have to answer. And this is going to be rare for us because we're just doing an overview and we don't have a super amount of time to go into the rational functions and graphing them with as much detail as it really deserves. The question we have to answer before we can draw is, does the graph go through the horizontal asymptote? So while it's true that a graph does not go through, so while it's true that a graph never, ever, ever goes through a vertical asymptote, it is possible that real close to the origin, a graph might, under certain conditions, go through the horizontal asymptote. It might pop through and then come back toward it, because the horizontal asymptote is telling me what happens a long way away as the x values get really, really big and really, really small. So this is a fairly easy test. I don't love the way, I know you guys don't have a copy of the book. I wish our book solved equations first and then did the graphing, because what we have to do here is we have to take the x minus 1 over the x plus 4. That's my function. And I want to know, does it ever go through the horizontal asymptote? So I want to know, does it ever go through this y value of 1? Okay, here's my horizontal asymptote. Oops, you can't see that on the screen, what I'm doing. Here's my horizontal asymptote. So what you do is you take that y value, and down here you say, okay, does my function ever equal 1? That'll tell me if it goes through the horizontal asymptote, and it'll tell me what x value. So again, this is done in poor order by our book, but we have to suffer through it. You've done this in intermediate algebra, so hopefully this is review. The way we do this, the way we clear the fraction, is we just multiply by this denominator on both sides. So I'm going to multiply by x plus 4 over here. I'm going to multiply by x plus 4 over here. This is kind of as complicated as the clearing the fractions will get in this section. We'll talk about it in more detail on Wednesday. But here the x plus 4s cancel on this side, and I have x minus 1. Here, 1 times x plus 4 is x plus 4. And when I go to get all my x's on the same side, notice the x's cancel on both sides. I have -1 is equal to 4. That is a contradiction. -1 is never equal to 4. And so this is false. And what that tells me is the graph never goes through the horizontal asymptote. One of our examples does. When it does go through the horizontal asymptote, you will get an x equals. You'll get an x value that happens at. So here's the good news. We now know the graph does not go through the horizontal asymptote. So we can now draw half the graph and we're almost done with the problem, I promise you. I've tried to boil this down because I know we're doing this kind of fast in just one class period. So I've just tried to make this as simple a process as we can. So now I know my graph never goes through a vertical asymptote. That is a given no matter what. And I've also just shown that this particular graph is not going to go through the horizontal asymptote. So over here on the right side, what we can do with these dots is say, okay, here's what's happening then. The graph is going to get closer and closer to the vertical asymptote and move down. And then since it's never going to go through the horizontal, it's just going to get closer and closer to that. The asymptote defines the behavior of the graph. It's not a perfect sketch, okay? I wouldn't use this to predict values, but what you're showing me when you do this is you understand the behavior of our rational function. And that's my biggest concern in our short and brief survey of it. So then what remains is, okay, I need to know what's going on the other side. And that's a great question. And so the last thing that we're going to do is you're just going to plug in a couple values. So we're going to plug in values as needed. If you just need to plug in one value, that's great. If you need to plug in 9 values, that's great. Do what you need to do to feel confident of what's happening. So after you write that down, I'm going to come over here. And here's step 6. I'm going to plug in a value. So I'm going to plug in a value that's to the left of this vertical asymptote. So tell me, what's your favorite value? What's your favorite X value to the left of the vertical asymptote? 0 is going to be over here on the right. Okay, so I already know what's happening on the right of the vertical asymptote, so I don't need to do that. But how about a value over here? Okay, -6. Yes, we'll plug this in. -6 sounds excellent. So what we're going to do is we're going to find the function value at -6. And so in the numerator, that is -6 minus 1. In the denominator, that is -6 plus 4. -6 minus 1 is -7. -6 plus 4 is -2. And when you pop that into your calculator, you're going to get a positive 3.5. So I'm going to slide over here to the right or the left, whatever direction that is. At the X value -6, we just found that the Y value is 3.5. So that's 1, 2, 3.5. Now, again, we're just doing a little sketch. My big premise is, do you understand how this graph is behaving? If you want to get another point or two to get a little more refined detail, be my guest. But now with that point and my knowledge that it's never going to go through the vertical or horizontal asymptotes, I'm going to finish the graph. So it's never going to go through this vertical asymptote. So it goes up like this. And then it's never going to go through that horizontal asymptote. So it's going to go like that. And I'm done with my sketch. Again, if you want to get some other points because you need to feel more confident, that is wonderful and lovely. Yes. Will you have to what? What I have done right here is my expectation on the test. If you want to go above and beyond that, that is your prerogative, you know, if you want to feel really good. But again, I'm not looking for super accuracy. I'm just looking for, do you understand at this point that the asymptotes are defining the behavior of that graph? And I'm good with that. Okay, again, we're doing this real quick. You know, if this was a, I wish this class had a little less material so we could focus a little more on some things, because there's a lot more fun stuff we could do with this, but I'm trying to be reasonable. Okay, great question. All right, so what I would like you to do, I'm going to leave this picture right here for a couple minutes. I'm going to give you 3 or 4 or 5 minutes. The problem right below it is super similar to what we just did so that you get to replicate the steps. So graph the function x plus 2 divided by x minus 3. I'm going to get started. Notice a few of you are still working, and that's great. Okay, so keep working, check your work with mine. I'm just going to go through the 6 steps. If you have a question at any point, if something I do looks wrong or you got something different, please don't be afraid to ask a question. This is hard stuff, okay? So, and I know it, and I want to make sure that we're doing a good job repeating it. All right, so the first thing is the vertical asymptote. Now, if you looked on the front page, you'll notice that this problem, we found the vertical and the horizontal already, but just in case you didn't realize that, the vertical asymptote, you always just take that denominator. Okay, where is the denominator equal to 0? That's where you have the problem. So that happens here at the x value 3. So hopefully at the x value 3, we're going to make a nice dotted line. So far, so good. I mean, if you on the test, if you're able to find the vertical asymptote and draw that dotted line, there's partial credit. Okay, so do everything that you can. I'm hoping you can get through the whole thing, but do whatever you can on these problems because it's all partial credit. Okay, that's why I don't give you the tests on my math lab. I've given to you right here. Okay, the next things 2 is the horizontal asymptote. Well, again, we did this already, but again, in case you didn't notice this, this is the situation where the powers are equal. Okay, just like the last problem, I just wanted you to work through a super similar problem. So since the powers are equal, this is the ratio of the 2 coefficients, 1 over 1. So y equals 1. So here's my horizontal asymptote. So again, that tells me a lot of information about the graph. The rest of this is just getting a few more details so that I can do my little sketch. The third thing I'm going to do is I'm going to find my Y-intercept, and I find the Y-intercept by plugging 0 into the function, by plugging x equal to 0. So that happens at 0 plus 2 in the top, 0 minus 3 in the bottom, or negative 2/3. So again, just a little bit below, closer to negative 1. First 3 steps. Anybody got a question, comment, concern, anything going on? Okay, step 4 is we're going to find what is the X-intercept. Where does it go through the x-axis? So we do that by setting the rational function equal to 0. Well, again, what I told you, the shortcut to this, the denominator doesn't impact this at all. It's the numerator that determines where the value is 0. So that is when x plus 2, sorry, I'm over here on the right, when x plus 2 equals 0, so x is negative 2. So I'm going to come back to my graph, to the x value negative 2. Now we're almost there. We're almost ready to start connecting dots. I do have one more question to answer, and that is, does the graph go through this dotted line? So does it? Well, what I'm going to do then is I'm going to take the x plus 2 over x minus 3. I'm going to set it to the y value of the dotted line, which is 1. And we're going to see the same thing here that we saw in my example that I did. We're going to clear the fraction by multiplying both sides by x minus 3. On the left side, that makes the x minus 3's cancel, and I'm left with x plus 2. On the right side, 1 times x minus 3 is x minus 3. And when I get the x's all on one side, I'm writing out this step just so that it's clear what's going on. I've got 2 is equal to negative 3. Again, that's false. So does this graph go through the horizontal asymptote? No, it does not. Okay, when you get a false statement here, that tells you the graph never goes through the horizontal asymptote either. And that's good news for my graphing. It makes my life a little simpler. As far as what I got right now, what this means is as I go backwards, the graph's just going to keep getting closer to the horizontal asymptote because it never goes through. And then as I go to the right, it never ever, under any circumstances, no graph goes through a vertical asymptote. So there's my left hand of the graph. And then it doesn't matter, just pick whatever whatever x value over here is going to help you see where it is. I'm going to pick 5. I have no secret magic reason for picking 5. If you pick 4 or 6, or if you're a glutton for punishment and you pick 5.25, you can pick any x value that you want. So here's step 6. I'm just going to plug in 5 into my function. So the numerator becomes 5 plus 2. The denominator is 5 minus 3. That's 7 over 2, and just my calculator tells me that's 3.5 because I often have an easier time graphing decimals. So I go to my graph, 5 and 1, 2, 3.5. Okay, great. If you want to get more points, you want to look, you don't feel super certain right there, that is great. But now I'm just going to, from that point, I'm going to go, okay, as I go further to the left, it's just going to keep getting closer to that asymptote. And then as I go further to the right, it's going to get closer to that asymptote. So far, we so good. We doing okay. I know this is difficult stuff. Okay, so flip the page. All right, we're going to try these problems. Now we're going to walk through these ones step by step together. So here we go. What I would like you to do, I'm just going to give you a minute to do each of these things. We're going to go one thing at a time. First thing, I want you to please figure out what are the vertical asymptotes. Little hint, there are 2 on this one. What are the vertical asymptotes of this graph? Go. All right, so here we go. What I'm going to do is I'm going to set the denominator equal to 0 because that is always our process for vertical asymptotes. So x squared minus x minus 6 equals 0. When we talked about this last week, I said, hey, at this point, if it factors, go for it. If you like factoring, but the quadratic formula will always work. This one does factor, and so I'm just going to go right for it. But if you use the quadratic formula, you'll get the same 2 values I get. The 2 factors of -6 that add up to -1 are -3 and +2. So that means my two vertical asymptotes are the x value 3 and the x value -2. So there's 2. So I'm going to make a nice dotted line here at the x value 3. And then I'm going to make a dotted line at the x value -2. At this point, I'm just going to call a timeout because I just want to make sure I address this adequately. Now that we have the vertical asymptotes, we can figure out the domain because, again, my graph never goes through vertical asymptotes. So I'm just going to give you 30 seconds just to see, can you piece together the domain of this? So right above this, I'm going to write domain and see if you can piece together what the domain is. Just a little hint, instead of 2 intervals on the ones we talked about last week, there's actually going to be 3 fun intervals on this one. So my domain starts at -infinity, And then as I proceed to walk along the x-axis, what's the first problem point that I have? Yeah, we're going to come up to this wall right here, -2, so we can't go through that. So I'm putting -2 in a parenthesis because that's where my vertical asymptote is, union. So now I get here in the middle and I go from -2, and then I'm walking along the x-axis. What's the next problem that I have? 3, yep. And then union, and then we're going to pick up at 3, and then I do not have any more problem areas. You could have more. There are rational functions that have lots and lots of vertical asymptotes, but not in this class. This is, for us, this is as complicated as they're going to get. All right, so once we're done with that, we found the domain, we found the vertical asymptotes. Step 2, find the horizontal asymptote. There's only one. Ask yourself, which situation is this? Turn back to the front page of your notes if you need to. Okay, which situation is this? Is this the first one we talked about where the power in the denominator is bigger? Or is this the second situation where the power in the numerator and denominator are the same? First situation, yes. And in the first situation, when the power in the denominator is bigger, notice the power is a 2. The highest power in the numerator is 1. When the power in the denominator is bigger, what is the horizontal asymptote, no matter what? Yes, it is. There you go. Y equals 0. So I'm going to make a nice dotted line right here. The x-axis is the horizontal asymptote. Yes, indeed. Step 3, I'd like you to please find the y-intercept, meaning plug a 0 into the function and see what you get. All right, when I plug 0 into this, in the numerator, I have 0 plus 1. In the denominator, I have 0 minus 0 minus 6. So in the numerator, 0 plus 1 is 1. In the denominator, 0 minus 0 minus 6 is -6. So -1/6. So something just a little bit below the x-axis. So I'm just going to make a dot there for funsies. The next thing, okay, again, I know we're getting into a little bit of uncharted territory because this function is slightly different than the ones on the previous page, but we're going to make the best of it and learn as we go. So what I would like you to do is figure out what the x-intercept is by setting this equal to 0 and figuring out where does this go through the x-axis. Okay, to find the X-intercept, meaning where does it go through the X-axis, I take my function, my X plus 1 over my X squared minus X minus 6, set that equal to 0. But again, just like the ones on the previous page, the denominator has nothing to do with this fraction being equal to 0. It's always the numerator. So that means the X plus 1, when is that 0? When's the numerator 0? And that happens at -1. So I'm going to put a nice dot here at -1. So the fifth part, does this go through the horizontal asymptote? Well, I think we can see the answer to that question from the point we just plotted, but I want to confirm that this doesn't happen anywhere else. So what we're going to do, I'm going to set this one up for you. I want you to give it your best shot. We're going to take the X plus 1 over the X squared minus X minus 6, and we set it equal to the horizontal asymptote, that value 0. So go ahead, I mean, we just did that. So I don't even know that I should have you, but let's go ahead and do this. So let's clear the fraction, so just in case we get to one, like the next one might be a little more complicated. So we'll clear the fraction, X squared minus X minus 6. We'll multiply that on both sides. On the left, it clears the fraction, and I'm left with X plus 1. On the right, the nice thing, 0 times anything is 0. And so I get the X value -1. So that tells me two things. It tells me, indeed, this graph does go through the horizontal asymptote, but it only goes through the horizontal asymptote in one place, and that is right here where I already know it does. Okay, so that means out here on the wings of this, left and right, it's not going to go through the horizontal asymptote. That's good news. That helps me, my graphing makes it a little easier. So now all that remains for me to do is to pick a couple points. So here's what I would like you to do. I'm going to give you 2 minutes. I'd like you to pick a point on the left part of this and the right part of this. And then I will help you with the middle after that. So don't worry about the middle just now. Okay, I want you to do the left part and the right part like we did our previous problems, because the asymptotes are defining the behavior of the graph. And then I will help you with the middle. Okay, so over on the left, again, it doesn't matter what you pick. All we want to do is we want to know where is the graph, and I'm going to then use the asymptotes. So I'm just going to pick the point -3. But if you pick -4 or -5 or something else, you're going to come to the same conclusion, I hope. So when I plug in -3 into this, in the top, I have -3 plus 1. In the bottom, -3 squared is 9. Minus -3 means plus 3, minus 6. -3 plus 1 is -2. 9 plus 3 is 12. Minus 6 is 6. So that's -1/3. So at -3, I'm at -1/3. So somewhere in there. And so again, if you want more points, get more points. But all I care about now is I'm going to use the asymptotes, and it's going to look something like this. So I'm just not going to extend it too far because I don't want to accidentally curve back out away from the asymptotes. Same thing over here on the right side. Pick whatever you want. I'll use 5. Okay, again, if you picked 4 or 6, we should all be coming to the same conclusion. So when I plug in 5, in the top I have 5 plus 1. In the bottom I have 5 squared is 25, minus 5 minus 6. So the top is 5 plus 1 is 6. In the bottom, that is 14. And 6 over 14 is something close to a half. 7 over 14 is a half. So 6 over 14, somewhere right there. So again, not super concerned about precision. I'm just concerned, do you understand what is going on with this graph and its relationship to the asymptotes? So it's going to look something like that. Now in the middle, here's what I'm going to do in the middle. I've got my asymptotes. I know that this goes through the horizontal asymptote, and it never comes back through. So what this tells me is on the left part of this, okay, my graph is going to be doing this, because it was below the horizontal asymptote, and then it goes through, and it never comes back through again, so it has to just kind of keep going up, up. So my question now is, what's going to happen over here? Now, you could use logic to deduce this. You could say, well, hey, Perkster, it doesn't go through the horizontal asymptote over here, so it must be going away from the horizontal asymptote, and that would be fine. But you also might say, well, I'd like to show myself that numerically. So what I'm going to do is I'm going to put in the value x equals 2, and this is going to be my final point that I get. So I'm going to find the value f of 2. So when I put in 2 in the top, that's 2 plus 1 or 3. In the bottom, 2 squared is 4 minus 2 minus 6. 4 minus 2 is 2, minus 6 is -4, so that's -0.75. So over here, it's like down here. And so, yeah, it's getting a little further away. If you put in a decimal, if you had the stamina to do that and you put in 2.5, you'd see it even gets a little further away from the horizontal asymptote. And so the graph is basically doing something like this. It's just doing a cut across, and it's going to approach that asymptote. All right, what we do, we have time for one more problem. I'll measure out our time next time to see if we're going to do anything on page 4. I might omit that from what we're doing, just depending on where we are. So with our final, we've got 15 minutes left. We're just going to go through this final problem on page 3. So again, we're just going to do it step by step together. In fact, I'm going to have you do the first 2 steps. Find the vertical, find the horizontal asymptotes of this problem right here. Step 1 and step 2. All right, so for step one, we're finding the vertical asymptotes. Vertical asymptotes always happen when the denominator is 0. You can use the quadratic formula. This one, you can actually add the 9 over and use the square root property. I'm just going to factor because that's what I like to do. So x plus 3, x minus 3. So that means I have 2 vertical asymptotes, one at -3, one at +3. This is the situation when I go to find the horizontal asymptote. This is the situation where my power in the top and the bottom are the same. So when the power in the top and the bottom are both the same, we take the coefficients in front of those terms. So it's 1 in the top, 1 in the bottom. So the horizontal asymptote is y equals 1. Now I'd like you to do steps 3 and 4. I'd like you to find the y-intercept by plugging in 0 into the function, and then find the x-intercept by setting it equal to 0. All right, when I plug in 0 into this, the function value at 0. In the numerator, I have 0 squared or 0. In the denominator, I have 0 squared minus 9. And so when 0 is in the top, 0 divided by anything is 0. So that is the point 0, 0. Which you also saw when you go to find the x-intercept and you said, okay, x squared over x squared minus 9 equals 0. All that matters there is the numerator. And when is x squared equal to 0? Well, you can take the square root in your calculator. The square root of 0 is just 0. So it's the same point either way. Your x-intercept and your y-intercept are the same point. So one more thing I want you to do, and then we will plug in a few points together. The 5th thing I would like you to determine for me, does this cross my horizontal asymptote? Does this graph go through that line y equals 1? So again, to figure out if it goes through the horizontal asymptote, you take the function, the x squared over x squared minus 9, and you always set it equal to the value of the horizontal asymptote. We want to know, does it take on that y value? Y equals 1. So we're going to clear the fraction on this, multiply both sides by x squared minus 9. On the left, that cancels. On the right, I have 1 times x squared minus 9, which is x squared minus 9. When I go to get all of my x's on the same side of the equation, I notice, oh, this is the situation where everything cancels, and I end up with a false statement. When my statement is false, you can make a note to yourself if you didn't know what to do with it now. When the statement is false, that means it does not go through the horizontal asymptote. Okay, it's never going to take on that value. So now, last step, here's what we're going to do. Like we did last time, I'm going to give you a couple minutes. I would like you to pick a value on each wing, okay, out here on the left and over here on the right, and determine what the behavior is on the wings, and then we'll talk about the middle together. It absolutely does not matter what values you pick out here. We will all come to the same conclusion. I'm going to plug in -4 just to the left of that leftmost vertical asymptote. And so when I plug in -4, the top is -4 squared, or 16. The bottom is -4 squared, or 16 minus 9. So that is 16 over 7. That's something that's a little more than 2. So at the x value -4, we are a little more than 2. So 1, 2 with a little bit. So again, I'm not interested in precision. We're just drawing a sketch. So now we're going to use that point and the fact that the graph, no graph ever goes through a vertical asymptote. This graph never goes through the horizontal. So I can just kind of complete my sketch like this. I'm going to do the same thing on the other side and plug in +4. And when I plug in +4, I get top 4 squared is 16. The bottom 16 minus 9, I get the exact same value. This function happens to be even. I didn't ask you that, but it is. So at 4, we got something a little more than 2. So again, whatever you plugged in, your sketch looks something like this on the sides. On both sides, it's above the horizontal asymptote, and it kind of fills in that gap right there. Now with the center here, now we could figure this out just logically. My graph is through this point. It never goes through the horizontal asymptote. So that means it's not going to point up because it never goes through. So that means both sides must be pointing down. Okay. But if you're not confident in that, and I don't blame you, I'm going to pick the point 2, and I'm going to plug in the function value at 2. And let's see what happens. So when I plug in 2, 2 squared in the top is 4. In the bottom, 2 squared is 4 minus 9. So that's 4 over -5, or -0.8 if you love calculators. So at the point 2, I get -0.8. And the same thing happens over here at -2 because we're squaring everything. So it indeed does move downward. And so our graph looks like is something like this. It's just going to go over toward those vertical asymptotes and move down. And again, I could have determined that logically just because I already figured out that it does not go through the horizontal asymptote, so it can't go upward. So that is, I think that's as far as we're going to go in this section. That's my expectation for you on the test, is that you can graph or do a little